Now we continue to look at finding areas using integration. Let's go over to our graph plotter GeoGebra and get something done here. Suppose we have y equals, let's say, 2x. Right, so we have this graph. Now it's showing y equals 2x. So you see that it is a line with the gradient 2. Now let me make the line thicker so we can see it even more clearly. So this is our graph. Y is equal to 2x. What we're going to do, what we're going to do is copy this graph and put it on our whiteboard. Alright, so I've copied it, at least part of the graph. This is the part we're interested in right now. Now, the thing is, suppose we consider drawing a certain shape, right? Let's say we draw this rectangle here. All right. We want to find the area under, below and to the right of our line. What's that area? Well, in this case, what we're doing is looking at half the base. It's this triangle we want, this triangle. Half times the base, which is 4, times the height, which is 8. Now, half of 4 is 2, 2, 8, 16. 16 square units. Now, if we find the integral from 0 to 4 of, this was y equal to 2x, 2x dx, we would have 2 times x squared over 2, which of course would go from 0 to 4, and then we have 2 cancel 2, so it's 4 squared over 2, no, 4 squared minus 0 squared, and that would be 16 minus 0. Alright, good. It would be 16. So our integration agrees with using the half base times height formula. Now what we did was say y is equal to 2 times x. Then we integrate 2x dx and got it. We could also find the area of this side over here using a similar technique. So let's erase this part, the shading. So we're interested in this side over here. Now, in this case, we imagine cutting up this side of the rectangle, of the triangle, into trapeziums. Alright? Now, before we do that, let's be reminded of what happened when we were over this side. How did we get that area? What we do is cut this triangle into trapeziums, I found the sum from 0 to 4 of the width, x is the width of each triangle, x, times the height. Now the height is x squared. So, no, it's 2x. The height is 2x. That's the height. Each height is 2 times whatever x is, times the change in x. So the change in x would be the width of each trapezium. Alright? And when we consider cutting it into an infinite number of trapeziums of zero width, the width approaches 0. Right? We say the limit as delta x tends to 0 of the sum from 0 to 4 of 2x delta x. The way you write it is the integral from 0 to 4 of 2x, and then the delta x becomes dx. Okay? Now, let us see what happens on the other side. Let's just erase it all and redraw our rectangle, which we cut into 2 parts, and we want to find the area over this side. Alright? Now, what we do is cut this into various trapeziums. The difference in width is now y. It's delta y, going from here to here. Alright? It's delta y. Now, suppose we find the area without using integration. What would it be? Well, it's a triangle too, you know. And the width is 4 and the height is 8. So the area is half times the base, which is 4, times the height, which is 8. Half of 4 is 2 to 8. 16 also. 16 square units. Now in this case, we're finding the sum from x equal 1 to 8 of what? Now it was the original equation. Oh no, let me redo that. The original equation was what? It was y equals 2x. But now we transpose and say x is equal to half y. Now we're summing up the y's, right? So we're summing from 1 to 8. It's going from 1 to 8 of half y. Delta x, right? Oh, delta y, I mean. Delta y. Half y, delta y. So here, if we consider these trapeziums, the width of each trapezium this way is half y. When we are at 4, we go down to 2. Remember, originally it was x equal 2, y equal 4. Now it's y equal 4, x equal 2. So instead of 2x, it's half y now. Alright? Now, if we cut this up into more and more trapeziums, we get trapeziums whose width becomes closer and closer to 0, right? They get thinner and thinner, closer and closer to 0. Now, so we have the integral from 1 to 8 of half y dy. Alright? Because we're saying x equal half y. So the area is equal to integral from 1 to 8 of half y dy. Now let's see what that gives us. Half y to the 2 over 2 from 1 to 8. Now here it is half over 2 of y squared from 1 to 8. What is half over 2? Let's just take care of the number here. If we multiply half by 2, we get 1. And if we multiply the bottom part by 2, we get 4. So half over 2 is really a quarter. But what we have is 8 squared. Oh, it's not 1, it's from 0. It's from 0. My mistake. Oh boy. It's from 0 to 8. We're adding up. We're going from 0 to 8. It's from 0 to 8. So we have a quarter y squared is 8 squared minus a quarter 0 squared. Alright, that's what we have. Now 8 is 64, so it's 64 over 4 minus 0 squared is 0, 0 times a quarter, 0. Right? So we can cancel down. 2 into 64 goes 32 over 2 into 4, 2. 2 into 2, 1, 2 into 32, 16. So we get 16 square units again. Right? So in this case, we're finding the area under the curve running upwards. So we're cutting up the y's instead of the x's this time. Alright? So here, we're going to do more examples similar to this in later videos. Alright? So I'll see you then.